All right, so what I'm going to do is I'm going to go through and give you some help or an example for each of these questions or chunks of questions. And if you send me an email with or a message with your answers to these questions, and I'll give you credit for them. So this first couple are on transformations, and I've put the rules over here on the right. It's important to know, like, for these transformations, we're starting off with the parent function f of x equals 1 over x. So that's what f of x is. So if I wanted to have this, and then I add 3. So if you have the function and then you add 3, that means that it's going up 3. Where if I instead, before I divided, I subtracted 2. That would be this one right here, moving to the right 2. So you're subtracting it kind of within that 1 over x. The first two for right and left, that's like, okay, you have your 1 over x, and then from that you add or subtract a number. That moves it up and down. Okay, so this same table is there to help you with question 16 as well. Now for the next couple, I just put this example moving from radical form to exponential form. So just look at the example and you should be able to figure it out. If there is a number under the radical that doesn't have an exponent, then you just assume that it's 1. So like this one would be 6. The inside number is the top of the fraction, the outside number is the bottom of the fraction. And then this one as well. So for the exponential rules, like whether what you do with your exponents, those are all listed over here on the right. So for this one, let me give you an example. If I have x to the 1/3 times y to the 1/6, all of that to the 12th power, this is the power rule. So if you have something with an exponent raised to a power, you multiply them. So this is x to the 1/3 times 12, which 1/3 times 12 is 4. And then y is to the 1/6 times 12, which 1/6 times 12 is 2. So you multiply the exponents. This one is very similar. Let me give you an example. If I have 81 x to the 12th, y to the 8th, same thing, it's the power rule, so you're multiplying the exponents. So if we look at the x's, we have 12 times the 1/4, that would be x to the 3rd. Or if we look at the y's, we have 8 times 1/4, which is 2. But for the 81, that is 81 to the 1/4 power. So now we need to go back to that exponential to radical to figure out what that is. Or you can put in your calculator 81 to the 1/4 power and probably tell you the answer. But just so you know, 81 to the 1/4 power is the same as 81. The top of the fraction goes inside, the bottom of the fraction goes outside. So you can also put that in your calculator. It's usually a button that looks like this with an N or an X here. So you put your 81 and then you change that number on the outside to a 4. And that would tell you that it's actually 3. Then compositions. So compositions is when you're taking one function and you're kind of putting it inside another function. So let me give you an example here. So in this example, I want to take that 1 over x to the 3rd and put it inside the g of x function. So instead of x, I'm going to put 1 over x to the 3rd. So I'm going to have a fraction with an exponent in the denominator raised to the 6th power, which is kind of messy. So what I'm going to do before I put that inside the g of x function is I'm going to change this to x to the negative third. That makes it a little easier. Remember, if you have a negative exponent, you can take that negative sign off and then move it all down to the denominator. So that's the same thing. So now I can put it inside the g of x. So I have 1 over, instead of x, I'm going to put x to the negative third to the 6th power. Now remember, if you have an exponent raised to a power, that's when you multiply. So this is the same as 1 over x to the negative 18th power. And then I can change that. If you have a negative exponent, you take that negative sign off. If it's already in the denominator, you move it up to the numerator. If it was in the numerator with the negative exponent, you move it down to the denominator. But since this is already down in the denominator, I just take that negative sign off and I move it up to the numerator. So I can just take that 1 away. Here's a little bit of different one with a radical, so let me give you an example. So for this one, I want to take f of x and put it inside of the g of x. So for this g of x function, wherever there's an x, I'm going to put this. Now, again, that's not in a good format for me, so I'm going to first change that to exponential form. Remember, the number on the inside is the top of our numerator, the top of our fraction. The number on the outside is the bottom of our fraction. So I'm going to use that instead. So I have 3, and then x to the 1/3 to the 4th power plus 1. And then you can start simplifying. So remember, if you have a number with an exponent raised to a power, you just multiply, and there you go. And then it looks like for this one, they're changing it back to radical form. So the number on the top goes inside, the number on the bottom goes outside. And so that would be your answer. Let's look at another one. This one, again, oh, this is finding the inverse. Okay, so let me give you an example. Okay, so when you're finding an inverse, just think inverse, reverse, backwards. You're switching the x and y. So the first step is wherever there is a y, you put an x. Wherever there's an x, you put a y. Now I just want to solve for y. So I'm going to add 1 to both sides. And now I want y by itself, but it's to a 1/2 power. So you want it to just be y. So you want to think, what can I do to 1/2 to make it like 1? I want the exponent to be 1. So if you think of it, 1/2 times 2 is 1. So what we're going to do is we're going to raise this to the 2nd power, and we're going to raise this to the 2nd power. Because remember, when you have an exponent raised to a power, you just multiply them. 1/2 times 2 is 1. So we have y to the 1st power. And then over on the left, I have x plus 1 squared. So it's just x plus 1 times x plus 1. So you do the FOIL method. And there you go. And just combine your like terms. Okay, and then the last one, this one, it's very similar. Let me give you an example. So again, if I wanted to find the inverse, I'm just going to reverse backwards. I'm going to change my y to an x. I'm going to change my x to a y. And then again, you're trying to think, what can I do to solve for y? What can I do to 1/6 to make it 1? Because y is just like y to the 1st power. So what I would do is I would take 1/6 and I can multiply it by 6. Now give me 1. So what I need to do to each side is raise it to the 6th power. So I have x to the 6th, and then 1/6 times 6 is 1. So that's your answer.